It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear. So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 242 of Science on Top for Sunday the 11th of September 2016. I'm Ed Brown and I'm joined by Penny Dumsday.
Hello.
And Lucas Randall.
Howdy.
Well, let's start off with the big news that the US Food and Drug Agency dropped last week. A bit of an announcement that I wasn't expecting. It took me by surprise. Basically, the FDA has announced that triclosan and triclocarban must be removed from all antibacterial soap products by late 2017. Penny, this is not so much about them being unsafe or dangerous, although there are possible long-term health effects, but mostly it's because they're no more effective than regular soap and water, is that right?
Yeah, they don't do any good, really. So I'm going to guess that at high concentrations in a hospital situation or something, these are very effective. Mm-hmm. But in the concentrations that they're usually found in soap products, and for the purpose of preventing spread of disease, and I'm sure we all know someone who is almost compulsively, scrubbing their hands with something antibacterial, and they'll squirt you with this and that. Anyway, I do.
Wait, you squirt people with antibacterial soap, or you just know someone?
I know and love those people, but
no one has ever squirted me with soap or anything else.
See, working in a school, there's a lot of consciousness of the spread of disease, and
which is good.
Some people do worry, and it's very hard to take your biology teacher off and just go, I am just a person working in this workplace and it doesn't affect me. But anyway, because it just doesn't really do anything more than soap and water. So a lot of what gets the bacteria, which may be on your hands, off your hands, is just the bubbling of the soap and the mechanical action and the, what's it called? The surfactants, which sort of make little bubbles and lift the bacteria away. The antibiotics that might kill and weaken bacteria are in such small concentrations, and what they're probably doing is just breeding stronger bacteria. So
it's that antibacterial resistance.
It's just always struck me as just completely ridiculous. So the other thing, which is I hadn't thought about, but which really makes sense, is most of the bacteria that are commonly involved in causing illness, things like E. coli, are not transferred hand to hand anyway.
Yeah.
They're from food. So, I mean, we all worry about catching a cold or flu, but that's viral and droplet infection, and antibacterial ingredients are not going to do anything to help that anyway. So the FDA
so it's a good
the
thing,
States,
really.
yeah, it's a great thing, I think, has banned it in soaps. It's not as great as it could be. It can still be used in hand sanitizers, so, those little bottles of alcohol stuff, essentially.
The things that don't need
water.
You
don't need water, yeah. You just wash them on your hands, which is, gives you a nice clean feeling in certain circumstances. And again, I think there's a lot of concern about the possible effects of these antibacterials in the environment and the way that they have the potential to disrupt human hormonal systems. But I don't know how well studied these are. I'm not an expert in this area by any means. So I think that it's, like Ed said, it's not so much that they're known to cause harm, but they're definitely not doing any good, and they potentially have effects on ecosystems. They're very persistent, apparently, and found everywhere.
I read that there has been traces of triclosan found in dolphins' blood.
Yeah.
Which it probably shouldn't be in there.
Yeah.
But I think also in terms of evidence and research, this is a debate that's been going on since 1978, and the FDA basically said to all of the cosmetics companies, the all the companies that are using triclosan, and said to them, look, provide us with evidence that it works. And they've had 30 years or more to do that, and they haven't been able to find any actual conclusive evidence that shows that in the concentrations that you use when washing your hands, that does any good at all. Now, I can understand that they haven't banned it from your hand sanitizers because maybe when you're leaving the chemicals on there for a time, maybe that can have some sort of effect, as opposed to just washing it off with water straight away. But who knows? And I guess that's the next step that the FDA will be looking at. But I think it's great that they've taken action, and we're so used to saying the FDA hasn't banned this or they haven't acted on this, and we always get criticism of the FDA. They've actually done something really good that will have long-term impact, I think,
and
which is great.
Personally, I hope it flows through here because I have found it harder and harder and harder to find non-antibacterial products
same.
to buy. And, like, I don't particularly want to pay $4,000 for the organic, harvested by monks kind of thing. Like, I just want a vat of... normal
soap, basically, or some sort of a liquid soap. And the organic, all natural sort of stuff probably is as ineffective as the antibacterial too.
Yeah.
Well, you basically just want good old-fashioned soap or something like sorbeline, which is a more gentle and moisturizing thing. You want something it's the abrasive action of washing underwater and actually brushing the bacteria off, as well as the mechanics that soap has where it will grab onto the dirt or the bacteria and will grab onto the water and it'll wash it away.
But apparently washing your hands with water is almost as good as with soap.
Yeah.
So, Anyway, I hope that this trickles through to other countries like Australia.
Well, we have seen some effects on this sort of scale with things like the banning of microbeads, the little plastic things that you get in your exfoliants and all that.
That's my other pet peeve.
Yeah, everything's got them in it.
Everything's got them.
Well, I think they've, if not been banned, I think last year we talked about there've been a lot of steps to reduce what industries can use them and everything. So we are hopefully going to see more non-microbead cosmetics and a lot less triclosan in our soaps. So
it is scary how things can get used just for marketing that are as powerful as antibacterial, and it really is just for marketing. Like, it's created
that's
this
capitalism.
sort of this need. Anyway, yeah, it is, isn't it?
Yeah, can't help that, I'm afraid. Lucas, let's have a look at space launches. And there was an unfortunate mishap last week when a SpaceX rocket exploded on the launch platform. I think it was the day before launch. No one was hurt, thankfully, but the rocket's payload was destroyed. It was a satellite that Facebook was hoping would help Mark Zuckerberg invade the privacy of millions more. Sorry, I read that wrong. It was a satellite that Facebook was hoping would help them bring internet connectivity to sub-Saharan Africa. So that was unfortunate, but not the end of the world. Satellites can be rebuilt, launches can be rescheduled. But the big space launch news came a day or two later. And have a listen to this.
5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Yes, OSIRIS-REx going to the asteroid Bennu and back. This is NASA's exciting mission that, if successful, will be the first time NASA has retrieved samples of an asteroid.
Oh, yeah. I mean, it's not the first time we've retrieved samples of an asteroid. No. Of course, a number of years ago, when was it? Back in maybe 2011?
Yeah, 2010, JAXA.
2010, yeah.
With the Hayabusa.
Yeah, exactly, which didn't really go quite according to plan, but there was some samples, returned in that, which was good. But this one is a lot more ambitious. So of course we're talking about the Japanese probe Hayabusa, I think it was called Hayabusa, and they came back from the Itokawa asteroid with like the equivalent of like a few atoms or something worth of material, or a
few grains of sand or something.
Yeah, that had like an impactor from memory where they shot a thing at the asteroid, and it was meant to blow up a whole lot of dust, and they were going to capture it, but something just didn't go quite right with that particular one.
Yeah, the mini lander didn't launch properly, or didn't land properly, I guess, more to the
yes.
point. There was also a lot of issues with getting it to there. I think a solar flare messed with the solar panels, and it had less energy to get there, which meant it got there later and had then less time to do its experiments and things. A lot of things just went wrong, but that's the credit to the engineering team. They kept working around them and fixing it. They had reaction wheels that died, and they were able to get some grains of an asteroid all the way back to Earth, which was commendable. Yes. And they're doing it again.
Well, this one is a little different, and the mechanism is quite different. So this little guy that's launching, it's going to now. What's the it's the OSIRIS-REx is the acronym.
Is the craft? Yeah. Oh God, the actual acronym for what it stands for.
It's the Origins Spectral Interpretation Resource Identification Security Regolith Explorer. I mean, and I've said many times that scientists, astronomers seem to go to extraordinary lengths to wrap the name of their instrument around an acronym that can be said like words.
Well, let's look at that. So you get Origins, Spectral Interpretation, Resource Identification. All right, they're buzzwords, but they're kind of related to it. I get that.
Yeah.
Then they've thrown in security.
Yeah,
which is, we need another S word.
I'm not sure where security comes into it, to be honest. So Regolith Explorer, fair enough. Regolith being the material, the ejector. It's like the stuff, the moon dust.
The gravel-like stuff, yeah.
Security, I'm not sure. Maybe that won them some like national security budget funding or something. I'm not. I just.
Oh yeah.
No idea.
Yeah. Homeland Security went. Oh, we'll be involved in that. Yeah,
that's good. Anything to do with security is good. We'll give you a few billion. Anyway, so it launched last week, I think it was, and it was a successful launch, which was fantastic because we just recently had another rocket blow up, which wasn't a NASA one. This was, so it was a good launch. Everything went to plan. It's right inside the launch window.
It's perfect, according to a NASA spokesman. A perfect launch.
Perfect launch. Which is really anything that doesn't fall into the category of it blew up and didn't deliver the payload. So anyway, this particular craft is going to this asteroid that's lovingly called 101955 Bennu. And I thought sort of Benemu as soon as I read that. Hi, Michaels. But we'll just call it Bennu. It's basically a 500-meter wide asteroid. It is considered a near-Earth object, so it does come very close to our orbit, in its orbit around the Sun. So it has, over the period of its lifetime that we've calculated, there's always the chance this could end up crossing our orbit when we're there at some point in time, but we've calculated out, quite a long period of time, and there's no immediate danger from this particular asteroid. But being a near-Earth object, it makes it a pretty good target for visiting, like this thing's going to do, but also for potentially grabbing it at some point in the future and maybe mining it. We could sort of use gravity tug or something to pull it into an Earth orbit and then actually use resources from this asteroid or other near-Earth asteroids. So it's an object of interest, shall we say. So OSIRIS-REx is going to make its way there. It's got quite a fairly long journey, but it's going to use a gravity assist from Earth to get there. And then when it gets there, it's got a whole lot of instruments. It's got these quite a suite of cameras. It's got
so it's not just going to grab a sample and return that. It's got lots of studying that it's going to do as well. That's good.
Yeah. So it's got cameras. It's got other ways of analysing minerals and I'm not sure whether they're spectro type instruments or what, but it also has this package return instrument, which is going to work very differently to the previous one. This one basically, after about a 4-year journey to get there, it's going to come up behind the asteroid and sort of sneak up on it. And I'm sort of imagining that.
Be very quiet.
Exactly. It's going to sneak up to it, and it slows to a very, very slow relative velocity compared to the asteroid. And I think in the final approach, it gains on the asteroid at something like 10 centimeters per second, which is really slow. That's like, as Phil Plait said on the Slate blog, on Bad Astronomy blog, that's slower than a mosquito. So we'll really the idea of this one is to match the speed of the velocity of this particular object almost exactly, gain up on it, and then more or less almost touch it, but basically blow some gas at the surface that will hopefully disturb dust and so forth, and then use a capture to try and grab some of this material out of the area, and then it'll drop back a little bit and consolidate, and then it can make several attempts at this, so it increases its chances of being able to grab materials. So once it's got materials, I'm not sure whether they can detect whether the sample collector is actually holding anything or not, because it can hold anything from about 60 grams up to almost 2 kilos. So can grab quite a lot. But apparently, a total of 3 attempts to see if it can grab anything. And then once it's done that and it's finished, after it's all staffed, it's about 3 years that it'll be operating around this asteroid. It'll then head back to Earth. It'll end up intercepting Earth's orbit again. It'll eject the sample return container, and that'll come down through the atmosphere with some heat shielding and a parachute and land somewhere. Scientists will go and grab that, and then OSIRIS-REx will basically head off into a sun orbit for the rest of eternity. So it won't contribute to space junk around Earth, which is nice.
Very cool.
And there's been a lot of discussion. In fact, I think maybe it was last week we talked about some new hypotheses around the formation of life. Was that on the show, or was that a conversation I had with a person? I can't remember.
We did. We were talking about hydrothermal vents and
yes.
So on.
Okay, good.
Is that right? Yeah, that was on the show. Yeah.
Okay.
You may also have discussed it with other people.
I may have. I don't know. So this is a carbon-rich asteroid, which means it's very possible that it might have organic compounds, because we don't really know, whether the organic compounds formed on Earth or were dropped here, maybe rained down on asteroids and comets and things like that. So that's really, really cool as well to find out, at what stage the building blocks of life, as we call them, had been, put together before they came. So it's kind of cool. I
just want to clarify. You said that there's very little chance that this is going to impact on Earth in the near future, sort of thing.
Yeah.
Is there any chance that we, by sending probes to it, may alter its trajectory and bring it closer to Earth and destroy all life? Hey,
that's so funny that you asked that, because when I was reading this before, what occurred to me was if you magnify over enough time, even the tiniest change can have an impact. So yes, potentially the probe and its gravitational effect on this asteroid, because it's not a particularly big asteroid, could have a measurable effect given enough time. But what I was thinking about was, if we do get to a future where we start bringing near-Earth objects into Earth orbit, at what point will they start interacting with each other, forming some sort of catastrophic, everything getting thrown at Earth? It's an interesting thought experiment, but I guess that's
and probably a great movie.
yeah. I can sort of imagine a future where they go, well, we calculated this out to this amount of time, but the cumulative effects of all these objects and blah blah blah. Yeah, it could be quite interesting.
And only Bruce Willis can save us.
We'll have to drill something. It is something, and of course this is one of the very ways that's proposed to deal with objects that are a threat to Earth, is to use something like a gravity tug, which is an object with sufficient mass that it has a slight effect on the asteroid, so that just parking it nearby in the same orbit can have a dragging effect, a very slight dragging effect, and then multiply that by 50 orbits or whatever it is, then it could actually slightly alter its orbit and pull it away from hitting us, or conversely, make it hit us. So who knows? Hopefully they've thought of that.
Yeah, it depends whether the evil genius or the good genius comes up with the plan to do it.
Do you think there'll be some guy, like in the movie, who will need supercomputer time, so will have to physically go and sit in the server room and plug a cable into the supercomputer to do that calculation? I think not.
Of course.
I think not, Hollywood.
Of course no, come on. Well, I think we're getting way off topic here.
If you're listening to this podcast and you followed this conversation thread, good for you.
There'll be a test at the end. No, there won't. There won't, because I don't know what happened. But I did some looking into other sample return missions, and obviously in the 70s there were moon samples from the NASA's Apollo missions and the Soviet lunar programs. But then there was like a 20-year break where, or more than that, where we just didn't do sample return missions anymore until 2004. I think it was Genesis mission, which collected samples of the solar wind, which is really cool.
Oh, I forgot about that,
Yeah, Stardust in 2006, which collected samples of a comet. We mentioned in 2010, JAXA collected asteroid samples with the Hayabusa probe. And now JAXA has another asteroid sample return mission on the way, the Hayabusa 2 probe. That's expected to get to 162173 Ryugu in 2018, study the asteroid for a year and a half, and return the samples to Earth in 2020. So 3 years before the OSIRIS-REx returns its samples. And China, of course, is planning a Chang'e 5 lunar sample mission next year. And if that's successful, it'll be the first moon sample return in over 40 years.
Wow.
Which kind of bugs me that, this is the 50-year anniversary of Star Trek. And in that time, we've sent people outside Earth's orbit 12 times, which is kind of annoying and limiting. But anyway.
And meanwhile, North Korea have got a mission to bring the entire planet Venus back to Earth, which apparently is...
What? Is that for real?
No, I made that up.
I believe it, though. It's the sort of thing that, But I was also, like, in the 1970s, when you had all these mad schemes, I mean, there was, I think it was in the 50s or 60s, there was a proposal to detonate a nuclear bomb on the moon, see what happens. But Russia had some crazy things too, like the Mars 5NM mission, which was going to be a sample return mission to Mars. They were originally going to launch it in 1977 or 1975 or something with a massive, supermassive rocket, sort of Atlas V type thing. That ended up being a real failure because the rocket kept blowing up and wasn't very good. So they went, all right, we won't do that. We'll use the Proton rockets, which they're still using today, and we'll launch it to a space station that we'll have in orbit, and from there we'll assemble the probe and launch it from space to Mars. But a lot of other failures and politics went by, and that didn't happen. But they are now looking to another Mars Grunt mission, they call it. Of course, Mars Dirt is what the translation there is. And I don't know when that's likely to happen. That's just in planning stages.
I think we've discussed that on the show at some point.
We've discussed Phobos Grunt, which was returning the sample from Phobos, the moon around Mars. And that didn't leave orbit and crashed into the ocean as well. So.
Yeah, that went horribly wrong.
Yeah. So this could be the return of the sample return mission, I guess. It could be that we're getting more interest in retrieving rocks from space.
Well, I hope the Russians finally have some success with Mars, because that's really...
That'd be nice, wouldn't it?
Yeah.
There's like 17 or 18 failed Mars missions from them. Well, let's... come back to Earth and talk about some fossils, shall we? And I think most people would be familiar with Lucy, the partial skeleton of a female Australopithecus afarensis, a distant ancestor of modern humans. It's also the fossil that gave its name to the terrible movie with Scarlett Johansson and Morgan Freeman. And now a team led by John Kappelman from the University of Texas at Austin has published a paper in the journal Nature theorising that Lucy died from a fall, probably from a tree. Penny, this lends some more weight to an existing idea that Lucy and her Australopithecine friends spent a lot of time in the trees as well as walking on the ground. They were a kind of evolutionary midpoint between our tree-dwelling ancestors and our ground-dwelling ancestors. Is that a fair approximation?
Yeah, I think so. So even though we think Lucy is on that path from in between a common ancestor of apes and humans to just humans, she's not considered a human in the genus Homo. So we can't say, oh, well, Lucy is a person, and Lucy was definitely a biped. So I think it's really interesting. I've as most people who've read a biology textbook or anything really about human evolution have heard of Lucy, I never really thought about how she died before and I guess I'd read, statements of, mostly bipedal and whatever, and just hadn't thought any more. But this,
well, I guess, sorry.
Yeah.
Also, when you consider that we've only got 40% of the overall skeleton,
yeah,
I'm surprised that we can guess at all about how she may have died, let alone how she lived.
Well, this comes from some really high quality CT scans of Lucy's skeleton. So when she was discovered, the scanning technology was pretty crude, but recently she was scanned, I think in 2008.
Yep.
And at a really high quality, and they noticed a series of fractures along her arms. So the long bone of her upper arm, and it looked like these fractures were the kinds that might have been caused by a fall from a great height. So the hypothesis is that Lucy fell from a tree. She, in a really, I guess, human-like gesture, put her hand out or her arms out to try and break her fall. And because there's not much healing from these breaks and from other breaks, it looks like this was the fall that might have killed her. And the fact that she was up a tree suggests that maybe this species still spent some time in trees for whatever reason. They might have lived up there for protection. Chimpanzees make nests up in trees, and sometimes apparently they do fall out of trees and can be injured. Who knows if she was hunting up there, gathering fruit. But yeah, it's really...
Or this could be just a one single data point, and maybe she was just climbing trees for fun or something, and none of the others did.
Have been, just doing it for all the reasons that we see on, 10 craziest YouTube epic fail kind of compilations.
She was the jackass of her time.
She was trying to take a selfie. No. Sorry, poor Lucy. Yeah. So I think I don't know, it made me feel a bit more of a connection to Lucy as an individual with a life and a story. But this is not
just a set of bones.
Not just a set of bones, but this is also not to say this is conclusively why she died. I mean, that's a hypothesis.
Yeah.
I don't think it's possible to rule out damage after her death.
I was really,
given that the bones are so old and everything.
I was really surprised at the detail of their analysis and how they extrapolated from that. Excuse me. They've said, if I can just read from it, it says they found many bones of Lucy's skeleton bear the fractures of a substantial fall from a tree, as you said, and the fall that ended her life. Lucy fell from high in a tree, hitting branches on her way as she plummeted at 60 kilometers per hour or more to the ground. Landing on her feet first, she fell forward. And as you said, very human and futile quest tried to break her fall with her hands. Her leg bones were fractured, knee joints destroyed. Lucy's pelvis was seemingly shattered into pieces. It goes on for quite a while. And then it talks about how she was conscious, what she thought about as she slipped into the abyss.
I will say, if you want a fairly detailed summary, then Ed Yong has done a great article about it in The Atlantic. If you want a really lengthy and in-depth history of the human race, including Lucy's death, then Darren Curnow from the Director of Paleontology, Geology and Earth Archives Research Centre at the University of New South Wales has done a tremendous breakdown of this and a number of other theories all about basically the journey from tree-dwelling apes to ground-dwelling Homo sapiens, really.
It is quite fascinating.
We'll try and have links to both of those in the show notes because it's very, very cool. I just love, as you say, the detail of it that you can... I think, Penny, you were saying that we're not sure if she died from these injuries or whether these injuries may have happened after it. There was speculation that because of the lack of any healing or anything happening to it and the nature of the breaks, that they are likely to have been before she died, but not after death. So, don't know. But it's very cool that we can do that sort of analysis on something 3.2 million years old.
I think we need a website now. Was Lucy murdered? Like a Twin Peaks sort of mystery. She was pushed out of a sleeping nest.
Yeah, did she fall or was she pushed?
Yeah.
Or did she jump? Who knows? Not us.
New to Netflix.
Oh, God. Oh, yeah. Making of a murdered fossil.
Yeah.
All right. Lucas, we haven't talked about the Juno spacecraft very much. We've touched on it a little bit. And mainly that's because we were going to do a whole episode all about it, but we kept having issues coordinating guests and organising a time when people could come together to do it.
Yes.
And I think we will still do that soon.
I think so. And what we discussed previously was maybe we'll just wait until there's some cool, data being returned from the mission anyway, because we were going to do that episode around the time it was arriving at Jupiter. And now we have got some nice data. We've got some nice pictures in any case.
Well, do you want to give us a quick summary of the mission and then tell us about these photos that we've just got back of Jupiter's polar regions?
Yeah, so I think we have discussed a little bit before about the Juno mission and how it's unique in its orbit around Jupiter. It has a polar orbit, so instead of going sort of around the equator or like you would see satellites going around the Earth, there's a lot of equatorial ones. And depending on how far away they either keep pace with the rotation of the Earth, making them geostationary, or they are much lower and they go sort of zip around a planet, like the space station, for example. Juno has this polar orbit, so it basically shoots around Jupiter north and south. So, it has a different perspective, certainly different from anything we've ever seen before. It also has a very, very elliptical orbit, so it has periods during its mission where it skims very, very close to the planet's surface, if you can call it that.
Atmospheric surface?
Yeah, the top of its cloud, shall we say. So, and that's actually, this last orbit that it just did, it was the closest it will get to Jupiter in its entire mission. So, And they said that in itself actually was a bit of an issue because they were so damn close. They actually lacked perspective on what they were looking at. A lot of the time it just looked like a thick haze because, they're really close to a gas giant. So you can imagine how...
We should have used the wild field camera on this.
That's right.
Wild or wide?
Yeah. So it has, I think, just under 40, like 35, 36, something like that, of these orbits that it will do. Over time, and this one came within like 4,500 kilometers or something above the clouds of Jupiter. So it was really, really close. And during that time, it took a whole lot of measurements. Its entire suite of instruments were active during this flyby, which is awesome. But bandwidth is a problem when you're that far out. So they've got data returning at something like several. What was it again? I remember reading it thinking, well, that's actually not much slower than my home internet. It was something like 40-odd megabytes or something that took a couple of days to come back or something like this. So I've lost it now in the article. I'm sure it'll pop out at me as soon as I finish the story. But it was pretty slow, the data return. But what has come back is some incredible photos of the north and south pole of Jupiter. Now, we've never seen the North Pole of Jupiter before. No other mission has been in a perspective to see that. Jupiter is kind of unique in the way that it is aligned. Excuse me. It doesn't have much of a tilt compared to the orbital plane. So, if you think of Earth's got something like just under 24 degree tilt. Saturn has got quite a tilt as well, which is why you can see the rings seem to change their position in its orbit, depending on where it is, which is really, really cool because you can look at Saturn at different times and either see no rings at all or, very prominent rings. And that's because of its tilt. Of course, this is what gives us our seasons. Whereas Jupiter only has like a 3 degree tilt. So it means that when we look at Jupiter, we only see more or less on, its sort of equatorial region and, that perspective from Earth. And other missions that have been there have only been in sort of equatorial orbits. So we've never seen the North Pole of Jupiter before. Now, if you recall, Ed, when we looked at Saturn with Cassini, Saturn had this huge hexagonal shape on its north pole, which are like, what the hell is that?
So bizarre.
It is so bizarre and so awesomely cool. It is actually some of those photos are among my rotating backgrounds on my computer. So I see it very, very often, but it has this weird hexagonal shape at the top of Saturn. Jupiter has no such thing. It's actually quite bland compared to the very vibrant rings that we're used to seeing in the heavily vibrancy increased photos that we see from various observatories. You look at Jupiter through a telescope and you pretty much see a pretty dull disk, but you can, depending on the size of the telescope, you can make out a few of its bands through even just a backyard telescope, which is really cool. But you don't see that vibrant colour. But some of these photos from that are vibrancy enriched, it's really quite stunning, the variation in colour that you see on the bands. Whereas on the North Pole, it's actually quite bland. You see a few eddies and whirls and some interesting patterns. But the South Pole, however, has some beautiful aurora. Jupiter has a very strong magnetic field, very, very strong. So it induces some incredible aurora at its poles, and some of these aurora were actually captured with in the infrared as one of the instruments of Juno. And again, these images released over the last week are just absolutely stunning. They're just beautiful, beautiful images. So I do encourage you to go and have a look. And this is just a taste, because we'll see a lot more from Juno over the rest of its mission. So it's one that I'm really, really keenly following.
Yeah, so we'll have links to those photos in the show notes, and I highly recommend checking them out because they're quite gorgeous. And I think that's our show. So for more information about the stories we talked about, check out the website, scienceontop.com/242. Why not leave a comment there, or let us know your thoughts on social media. And you can always email us, feedback@scienceontop.com. And remember, the best way you can help us is to leave a nice review on iTunes. Help us get the word out. Lucas, Penny, thank you both for another great show.
Thank you, Ed.
Thanks, Ed.
And thank you everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
So you take the Tim Tam, right? And they're rectangles. So you bite off a little bit of one corner of the rectangle. Then you go to the hypotenuse down to the other corner. You go bite off that other little corner. And now that becomes a straw. So you take the Tim Tam, put one corner in your mouth, and you can breathe through it. Dip it in the hot liquid. And then you suck the liquid in only for like 2 seconds. And what happens is the hot liquid renders the middle of the Tim Tam molten. And then when you bite it, it just dissolves explosively on your tongue. And it transforms the Tim Tam experience into, it's another moment in your life experience that you can chalk up and say, that was different from anything else I've ever experienced.